Ever been in a situation where something needs to get done, right?
Yeah.
And there may be multiple ways to do it or different people who could handle it, but it's not totally clear which one is best.
Oh, absolutely. That feeling of, who's actually supposed to take this, it's pretty common. And it's really the heart of what we're diving into today.
Right.
We're going to unpack the change responsibility design pattern. Think of it like setting up a relay race for a task.
A relay race. I like that.
Yeah, the request gets passed baton style from one person or object to the next until someone goes, yep, I can handle this.
Okay, so our mission for this deep dive is to really get under the hood of this chain of responsibility thing. We want to see, how it works, what it's made of, and crucially, why it's actually useful. Why would someone use this?
Exactly.
So the core idea, according to this source, it starts when someone needs a problem solved, but they don't necessarily know who or what is the perfect fit to solve it.
Right. But they do have a list, basically, a list of possibilities.
And it's not just a random list, is it? The source talks about a chain.
Precisely. That's key.
Yeah.
These potential solvers are ordered, lined up, and the request doesn't just, get blasted out to everyone. It goes to the first link in that chain.
Okay, let's make this concrete. The source gives this really good example involving a hotel.
Yes, the notification example.
Yeah, they want to notify their loyal customers, maybe about a special offer or something. And they could use SMS or they could use email.
But here's the tricky part.
Right, the catch.
Yeah.
Some customers, you only have their phone number. Others, maybe just an email. And some poor folks, you might have neither contact detail on file.
Which creates this handling problem, right?
Yeah.
The system needs to be smart about it.
Exactly. It needs to try SMS if there's a phone number.
Okay.
If not, then it should try sending an email, assuming an email address exists.
And if you strike out on both.
Well, that's the third condition. If there's no way to contact the customer directly, the system needs to, raise a flag.
Mm-hmm.
In the hotel case, it notifies the manager.
So just boiling it down from the source's description.
Yeah.
The challenge is getting these notifications out effectively, given the different contact data for each person.
Mm-hmm.
And there's a clear pecking order. SMS first, then email, then escalate to the manager.
Okay, so this scenario feels tailor-made for this pattern. Our source then gets into the nuts and bolts, the structure and participania, which is just structure and participants.
Yeah, the components. There are a few key roles here.
First up, the handler. The source calls it notificator in the example. This sounds like the blueprint.
That's a good way to put it. It's typically an abstract class or maybe an interface. It defines the standard way requests are going to be processed, the common rules of the road for everyone in the chain.
Gotcha. And then you have the actual runners in the relay race.
Exactly. The concrete handlers. So in our hotel example, these are the real classes doing the work. Notificator SMS, notificator email, and notificator manager.
Ah, okay.
These specific objects are the ones linked together to form the chain. Each one knows how to do its specific job, send an SMS, send an email, or alert the manager.
All right, players identified. Now, how does the request actually flow? How does it move down this chain? The source has this implementer section, implementation.
Well, what's quite neat is that the abstract handler, the blueprint, often handles knowing who's next.
Oh, okay.
So each concrete handler, like the SMS one, has a reference, a link, to the next handler in the sequence.
So let's walk through it. The request for, say, customer Bob comes in.
Yeah.
It hits the SMS handler first.
Right.
If Bob has a phone number, the SMS handler sends the text, and that's it. Job done.
Job done. The request stops there. But crucially, if Bob doesn't have a phone number.
Then the SMS handler says, not my job, over to you, and passes the request to the next link.
Exactly. It calls the handle method on the next handler in the chain, which is the email handler in this case. It's like escalating a support ticket.
Makes sense. So the email handler does its check. Got an email for Bob. Send it. No email.
Then it does the same thing, passes it on down the line to the manager handler.
Right. And the source makes a point about the last handler.
Yes, this is important. The final link, the manager notificator here, it knows it's the end. It performs its action notifying the manager, but it doesn't try to pass the request any further because, well, there's nowhere else to pass it.
Okay, that prevents things from just falling off the end or going in circles. It's a defined endpoint.
Precisely.
Now, the source also mentions another example, something maybe a bit more technical, DNS resolvers.
Ah, yeah, that's a great real-world example. Totally different domain, but same principle.
How does that work?
Well, when you type, say, google.com into your browser, your computer needs the actual numerical IP address for Google servers.
Yeah.
A DNS resolver is the thing that finds that address.
Mm-hmm.
And it might do it by trying a chain of sources. First, it might check a local cache on your machine.
Yeah.
The address already stored there.
Okay, makes sense. Faster.
If not, it passes the request to maybe your router's DNS cache. Still no luck. It goes to your internet provider's DNS server.
Ah, I see the chain.
Exactly. It keeps forwarding the request up the chain of DNS servers until one of them knows the answer and sends it back. Same pattern, different problem.
That really helps solidify the idea. It's not just for notifications. Okay, the source also mentions correlations with other patterns, specifically the composite pattern.
Yeah, it points out a structural similarity there.
How so?
Well, both patterns kind of involve hierarchies. In composite, you build tree structures where, a component can contain other components. A parent node might delegate something to its children.
Right.
In chain of responsibility, while it's usually linear, not a tree, there's a similar idea of delegation. A handler passes the responsibility to its successor, which is structurally kind of like a parent passing something to a child or, well, the next element. It's a bit abstract, but the link is there in how responsibility flows.
Interesting connection. So let's bring this back home. Why should our listeners, really care about this pattern? What's the big win?
I think the main benefit and the source highlight to this is decoupling. It separates the sender of the request from the receiver.
Meaning the part of the code that says notify this customer doesn't need to know exactly whether it's going to be an SMS, an email, or a manager alert that ultimately happens.
Precisely. It just throws the request at the start of the chain and trusts the chain to figure
But
it out.
it gives you flexibility.
Huge flexibility. You can add new handlers, like maybe adding a WhatsApp notifier to our hotel example later.
Ooh.
Yeah. Just slide it into the chain. Or you could reorder the existing ones, maybe try email before SMS sometimes. You can make these changes without messing with the original code that initiated the notification request.
That sounds really powerful for keeping code clean and maintainable, less tangled dependencies.
That's the goal. Loose coupling makes systems easier to change, easier to test, easier to understand.
All right, so wrapping this up, we've done a deep dive into the chain of responsibility pattern using our source doc as a guide.
Yep, the core idea. Passing a request along a line of potential handlers, like a baton pass.
Until one steps up and says, I got this.
Exactly.
And we saw how the hotel notification problem, SMS, then email, then manager, was a perfect illustration. Each step handled its part or passed it on.
And we also touched on the DNS resolver as another example, showing this isn't just for one type of problem. It's a more general strategy.
So maybe a final thought for everyone listening. Think about other situations, maybe even stuff outside of software development, where you have a task and there are multiple steps or multiple people who could potentially deal with it depending on the specifics.
Ah, interesting. Like troubleshooting something at home, maybe?
Yeah.
Check the plug, then the fuse box, then call an electrician.
Exactly. How could applying these chain of responsibility principles, defining the handlers, linking them in order to make those kinds of processes, smoother and more structured?
That's a great takeaway. It's really about creating these clear, intelligent paths for problems to find their solutions. Food for thought.